The vast majority of certified aircraft reciprocating engines operate on the four-stroke cycle, sometimes called the Otto cycle after its originator, a German physicist. The four-stroke cycle engine has many advantages for use in aircraft. One advantage is that it lends itself readily to high performance through supercharging. In this type of engine, 4 strokes are required to complete the required series of events or operating cycle of each cylinder. 2 complete revolutions of the crankshaft, that's 720 degrees, are required for the 4 strokes. Thus, each cylinder in an engine of this type fires once in every 2 revolutions of the crankshaft. In the following discussion of the 4-stroke cycle engine operation, note that the timing of the ignition and the valve events vary considerably in different engines. Many factors influence the timing of a specific engine, and it is most important that the engine manufacturer's recommendations in this respect be followed in maintenance and overhaul. The timing of the valve and ignition events is always specified in degrees of crankshaft travel. It should be remembered that a certain amount of crankshaft travel is required to open a valve fully. Therefore, the specified timing represents the start of opening rather than the full open position of the valve. During the intake stroke, the piston is pulled downward in the cylinder by the rotation of the crankshaft. This reduces the pressure in the cylinder and causes air under atmospheric pressure to flow through the fuel metering device, which meters the correct amount of fuel in proportion to the air ingested by the cylinders. The fuel and air mixture passes through the intake pipes and intake valves into the cylinders. The quantity or weight of the fuel and air charge depends upon the degree of throttle opening. The intake valve is opened considerably before the piston reaches top dead center on the exhaust stroke, in order to induce a greater quantity of the fuel and air charge into the cylinder and thus increase the horsepower. The distance the valve may be opened before top dead center, however, is limited by several factors, such as the possibility that hot exhaust gases remaining in the cylinder from the previous cycle may flash back into the intake pipe and induction system. In all high-power aircraft engines, both the intake and the exhaust valves are off their valve seats at top dead center at the start of the intake stroke. As mentioned above, the intake valve opens before top dead center on the exhaust stroke, which is called valve lead, and the closing of the exhaust valve is delayed considerably after the piston has passed top dead center and has started the intake stroke, which is called valve lag. This timing is called valve overlap and is designed to aid in cooling the cylinder internally by circulating the cool incoming fuel and air mixture to increase the amount of the fuel and air mixture induced into the cylinder and to aid in scavenging the byproducts of combustion from the cylinder. The intake valve is timed to close about 50 to 75 degrees past bottom dead center on the compression stroke as the piston is moving up the cylinder depending upon the specific engine to allow the momentum of the incoming gases to charge the cylinder more completely. Because of the comparatively large volume of the cylinder above the piston when the piston is near bottom dead center, the slight upward travel of the piston during this time does not have a great effect on the incoming flow of gases. This late timing can be carried too far because the gases may be forced back through the intake valve and defeat the purpose of the late closing. After the intake valve is closed, the continued upward travel of the piston compresses the fuel and air mixture to obtain the desired burning and expansion characteristics. The charge is fired by means of an electric spark as the piston approaches top dead center. The time of ignition typically varies from 20 degrees to 35 degrees before top dead center, depending upon the requirements of the specific engine, to ensure complete combustion of the charge by the time the piston is just slightly past the top dead center position. Many factors affect ignition timing, and the engine manufacturer has spent a lot of time and effort testing to determine the best setting. All engines have devices for adjusting the ignition timing, and it's really important that the ignition system is timed according to the engine manufacturer's recommendations. As the piston moves through the top dead center position at the end of the compression stroke and starts down on the power stroke, it's pushed downward by the rapid expansion of the burning gases within the cylinder head with a force that can be greater than 15 tons or 30,000 psi at maximum power output of the engine. The temperature of these burning gases may be between 3,000 and 4,000 degrees Fahrenheit, or about 1,650 to 2,200 degrees Celsius. As the piston is forced downward during the power stroke by the pressure of the burning gases, the downward movement of the connecting rod is changed to rotary movement by the crankshaft. Then, this rotary movement is transmitted to the propeller shaft or the propeller gear reduction system to drive the propeller. As the burning gases are expanded, the temperature drops to within safe limits before the exhaust gases flow out through the exhaust port. The timing of the exhaust valve opening is determined by, among other things, the need to use as much of the expansive force as possible and to scavenge the cylinder as completely and quickly as possible. The valve is opened considerably before bottom dead center on the power stroke. On some engines, that's 50 to 75 degrees before bottom dead center, while there is still some pressure in the cylinder. This timing is used so that the pressure can force the gases out of the exhaust port as soon as possible. This process frees the cylinder of waste heat after the desired expansion has been obtained and avoids overheating the cylinder and the piston. Thorough scavenging is very important because any exhaust products left in the cylinder will dilute the incoming fuel and air charge at the start of the next cycle. As the piston travels through bottom dead center at the completion of the power stroke and starts upward on the exhaust stroke, it begins to push the burned exhaust gases out the exhaust port. The speed of the exhaust gases leaving the cylinder creates a low pressure in the cylinder. This low or reduced pressure speeds the flow of the fresh fuel and air charge into the cylinder as the intake valve begins to open. The intake valve opening is timed to occur at 8 to 55 degrees before top dead center on the exhaust stroke on various engines.